Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 2 Machines. We will be discussing about machines and the technical term, important terms that is being used in this chapter. Ready? Let's start. First of all, what we need to understand is what a machine is. We are using the word machines every day. What is a machine? Machine in simple word is something that makes our life easier. Okay, here you can see a boy is traveling in a cycle. He is cycling. Okay, traveling becomes easier when he has a cycle. Now, a scissor. Why is a scissor used? To cut papers. So cutting papers or cutting clothes becomes easier when you have a scissor with you. Or a grass cutter. Using grass cutter, cutting of grass becomes easier. When you have to lift water from a well using a bucket and a pulley. So by pulling the rope, it becomes easier. To take the water from the well becomes easier using a pulley and a rope. So there are many different examples. When you compare your life with the life that your parents had or a grandparents' childhood, we have many more machines. Okay, what they used to do? They used to do with everything with their hands. But we have got machines. Machines are making our life much easier. We have mobile phones for communication. To wash clothes, we have washing machines. So, machine is something, in simple words, it is something that makes life easier. Okay, easy. Everything can be done easier compared to when we do with the hands. Okay, first two important terms that we'll be using throughout this chapter is load and effort. We need to understand what load is, what effort is. So here you can see a person is trying to lift a stone. Okay, to lift a stone he is applying a force. Why can't he lift it with his hands? There comes the use of a machine. Machine is making it easier for him. Here he is using a metal bar. Okay, or a wooden bar. Using this, the lifting of the load becomes easier. So this load is the stone. Okay, here we are using a stone. This stone is to be lifted and the stone is the load. Okay, to lift this load, he is applying a force. A force is being applied on this metal bar or a wooden bar. This force applied on the metal bar, here metal bar will be acting as a machine. Okay, this force that is applied on the machine in order to lift the load is called effort. Okay, in simple words, we can define load is the resistive or opposing force to be overcome by a machine, and the effort is the force applied on the machine to overcome the load. Clear? Here we have load and effort. This is the opposing force. Okay, we need to apply a force in order to lift this load. Gravity is always acting downwards. So in order to lift it, that is to take it upwards, we need to apply a force. This force is what effort is. Understood the simple two terms? Okay, now we'll be discussing the four important uses of machines. Okay, what are the uses of machine? How does machines help us? First one is machines as a force multiplier. Multiplier means many times increase is happening. It can be 2 times or it can be 3 times, 4 times, etc. So force multiplier means the applied force is being multiplied twice, thrice or 4 times. This is what the meaning is. Okay, here when you consider a car jack, what does a car jack do? It is a machine. Okay, this car jack helps us to lift the car more easily. Can you lift a car with applying a force with your hands? No, right? But when this force is applied on the car jack is a machine and it helps us to multiply the force and lift the car. So, normally we cannot lift the car. Only when using a car jack you can lift the car. Here what is the load? Car is the load in this case. Okay. Let us say we are applying a force. Let us say we are applying 100 Newton's force. Using this 100 Newton force, you cannot lift the car. But when this 100 Newton force is being applied on the car jack, what happens? The car jack will multiply it. Okay. Let us say it becomes 200 Newton. It changes to 200 Newton. Which means this 200 Newton force can help us to lift the car. Okay. Now here you have nuts. To cut these nuts, you will be using nut cutter. Okay, you will be applying a small force. Normally, when you use the hands, you cannot easily cut this. To break this, what is used? A nut cutter is used. So, load is higher in this case. In this case, when you come to the case of a machine as a force multiplier, load will be greater than the effort. Effort is the force that is applied. This force applied will become many times. Therefore, load is always greater than effort. Just take this example. Here, car is the load. Effort is the force that we are applying. It is being multiplied. Yes, for example, you will be having load and effort. Load will be, say, 10 times the effort. Or load will be 2 times the effort. This is how it goes. Load will be always greater than the effort. Okay. Depends on the machine. How many times does it multiply? It depends on the machine that is being used. Clear? How machines will act as force multipliers? Here we have another important term which is mechanical advantage. This term will be using throughout this chapter. It is nothing but the ratio of load to effort. Okay? The ratio of load to effort is called mechanical advantage of a machine. It is represented by MA. Mechanical advantage is represented as MA. Mechanical advantage MA is equal to load divided by effort or output force by input force. Take the example we have taken before, that is in case of a car jack, you are applying 100 newtons force. Okay. This 100 newtons becomes 200 newtons. Okay. It is multiplied. A force multiplier. A machine is a force multiplier. We know that a machine is a force multiplier. We are applying 100 Newton force and it gets converted to 200 Newton. This 200 Newton force helps us to lift the car. In this case, the input force is 100 Newton. 100 Newton is the input force. What about this 200 Newton? It is the output force. Okay, when you take the ratio, that is load by effort. Here 200 Newton is the load and 100 Newton is the input force or the effort. Now our car will be having, to lift the car you will have to apply 200 Newton force. To apply 200 Newton force, who is applying? The machine, that the car jack is applying 200 Newton. For that we are applying a force of 100 Newton, which is the effort. Now tell me, what is the mechanical advantage in this case? It is the ratio of load by effort. Here it is 200 divided by 100, which is equal to 2. Okay, mechanical advantage is 2. So we understand that when the load is greater than effort or output force is greater than input force. In this case, output force is greater than input force. Then you will be getting mechanical advantage to be a value which is greater than 1. Okay, mechanical advantage is a value that is greater than 1. 2 is greater than 1. Okay, now if the output force is less than input force, then what happens? Here when output force is greater than input force, numerator is greater than denominator. When numerator is greater than denominator, you will be getting the ratio to be a value that is greater than 1. When the output force is less than input force, what does it mean? Output force is a smaller value compared to the input force. Yes, output force is having a value that is less than the input force. Numerator less than denominator. In that case, we will be getting mechanical advantage to be a value that is less than 1. Mechanical advantage less than 1. Okay, when the load and effort becomes equal. When load is greater than effort, mechanical advantage is greater than 1. When load is less than effort, mechanical advantage is less than 1. What about load becoming equal to effort? That is output force equal to input force. What can we say? When output force is equal to input force, then the value, the ratio will be equal to 1. Mechanical advantage is equal to 1. We understood that this is a ratio. When it is a force, you will be having unit of force Newton. Denominator also it is a force, the unit is Newton. What about the unit of mechanical advantage then? Since it is a ratio, there is no unit. Okay, mechanical advantage is a quantity that has no unit. Clear? So this is the idea about mechanical advantage. So we understand that when the load is greater than effort, mechanical advantage is greater than 1. Output force greater than input force, mechanical advantage greater than 1. Load is equal to effort, mechanical advantage is equal to 1. And load is less than effort, mechanical advantage is less than 1. Okay, study this table. Depending on the load and effort, what changes happens to the mechanical advantage? Is it greater than 1, equal to 1 or less than 1? Now the second uses machines for a gain in speed. That is how the machines can be used to obtain a gain in speed, to increase the speed. Take the case of a scissor. At the handles you will be applying force, right? So this is where you will be applying force. When the force is applied, there is this displacement to its position. Okay. Now here we have the blades. So this blades, what happen when you cut a cloth? The blades will be traveling through this cloth through a longer distance with a greater velocity. Here we have made the small displacement by applying a force. With a greater speed it will be traveling, that is the blades are longer. Okay, compared to the handle, the blades are longer and they will be traveling through this cloth and helps in cutting the cloth more easily. Okay, so this is again a machine that is making the cutting process easier. Here what has been done? It is not doing anything, that is force is not getting multiplied. In the previous case there should be an increase in force. Here is there any increase in force? Force is not increasing. Force is not increasing. What is happening? Here the speed is increasing. Gain in speed, velocity is increasing. Same is the case with the grass cutter. Why do we use grass cutter? Because here again in the handle you will be applying a force and the cutting of the grass becomes easier. Okay, so you just need to move this and the grass will be easily cut. Understood what does it mean by machines for a gain in speed? How machines helps in gain in speed? Related to this, you have a term to study, that is velocity ratio. It is nothing but the ratio of velocity of effort to the velocity of load. Okay, to calculate velocity ratio, you need to know the velocity of the effort and velocity of load. When you took the case of scissors, you know the scissor handle is moving. We are applying a force and the scissor handle is moving. That is a distance moved by the effort. Effort is a force we apply. Okay. Distance moved by load. What is distance moved by load? How the blades are moving. How longer distance the blades are moving. Okay. Now, in this case, we know that velocity is the ratio. Velocity is displacement divided by time. Velocity is displacement by time. Okay. Now, velocity of effort. With what velocity does the effort move? VE will depend on the distance that the effort has moved and the time taken. Distance or the displacement of effort, distance moved by effort is represented by DE. Okay. In time t. DE by t is the velocity of the effort. Now, what is velocity of load? VL will be equal to distance moved by load, displacement of load, that is DL divided by time taken t. Okay, now take the ratio. Velocity ratio will be equal to velocity of effort. Here velocity of effort is dE divided by t, divided by velocity of load, that is dL divided by t. Okay, taking the reciprocal and multiplying, we get dE by t into t by dL. T gets cancelled, that is dE divided by dL. Okay, velocity ratio is dE by dL, where dE is the distance moved by effort and dL is the distance moved by load. Okay, dE divided by dL. Now, when we considered machine as a force multiplier, we got the mechanical advantage to be greater than 1. Why? Because load is greater than effort. In the case of mechanical advantage is the ratio of load to effort. Load by effort, we will be getting a value that is greater than 1. When it comes to a machine as a speed gainer, what happens is mechanical advantage will be less than 1, because here velocity is important, not the force. Okay, so in case of a machine as speed gainer, and this is the case of machine as a force multiplier. Okay, in case of force multiplier, we got mechanical advantage to be a value greater than 1. Here it is a value less than 1 because force will be the same. Here force is not important. What is important? The speed is important. Clear? Speed is important. Now, what about the velocity ratio? When you take the case of a force multiplier, the initial stage, that is, the effort will be greater. Okay, the velocity of effort will be greater compared to the velocity of load. Load will be lifted through a small height. Consider the case of a car. The car is lifted to a small height, but the effort we are applying is a more distance. Therefore, velocity ratio will be having a value that is greater than 1 in case of a force multiplier. Okay. And the velocity ratio for a machine acting as a speed gainer will have a value less than 1. Speed gainer. Just take the example of scissor. We know that it depends on the distance moved by effort and distance moved by load. Here, effort is moving a very small distance. The handles of scissors is moving a very small distance, but the distance travelled by the load is more higher. Load is moving a more higher distance. Load is a blade. Blade is moving a greater distance. So therefore, the distance moved by the effort to the distance moved by load will be having a value less than 1. Why? Because this value, numerator, is less than the denominator. Therefore, the value will be less than 1. This is how we get the velocity ratio less than 1 in case of a speed gainer. Machine as a speed gainer. Clear? Third use of a machine is in changing the point of application of effort to a convenient point. Here you can see a machine, that is the cycle. Okay. What is the cyclist doing? He is pedaling. While pedaling, what happens? He is applying force to the pedals, that is up and down, to or fro motion is happening here. Okay. How does the body move? That is, the machine will be moving in this direction. Yes. How? Here force is applied which helps the wheels to rotate. This chain helps the wheels to rotate. Okay. When the wheels rotate, he is moving in this direction. So force is applied here at this point. This is a convenient point. At this point, we are applying force and the body is moving in this direction. It is not necessary that the cycle should be pushed. Okay. In the same direction when force applied, in that direction displacement is not happening. In this case, here the machine helps us to apply force here. This to and fro motion is happening while cycling, that is while pedaling. The chain will be moving, the wheels will be rotating and the body will be moving forward. Okay, here more force you will be applying, more faster rate it will be moving. That is, load and effort will be equal. More load, more effort. Okay, or more effort, more load. What about the velocity? When you pedal faster, the body, that is the cycle, will be moving faster. That is, the velocity of load and the velocity of effort will also be equal. When you increase the speed by pedaling, when you increase the pedaling, the speed of the cycle will also increase. When you decrease the pedaling, the speed of cycle will decrease. Okay. Therefore, we note that the mechanical advantage, which is the ratio of load to effort, will be having a value equal to 1. Similarly, the velocity ratio, which is velocity of effort to velocity of load, the ratio velocity of effort to velocity of load will also be equal to 1. The value will be equal to 1. Clear? Okay, so we have studied in case of force multiplier, mechanical advantage and velocity ratio are greater than 1. In case of machine as a speed gainer, mechanical advantage and velocity ratio both are less than 1. When it comes to this case, that is application of effort to a convenient point, there the mechanical advantage and velocity ratio we are getting equal to 1. Clear? It is equal to 1. And the fourth use of a machine is in changing the direction of effort to a convenient direction. Here, in order to lift water from a well, what we will be doing? We need to apply a force to pull this rope. Here, the machine is the pulley that is used. Okay. Why is a pulley used? A pulley makes it easier to lift water from the well. Or else what we'll be doing? We'll be having to hold the rope here and we'll have to lift it. Okay. In that case, force of gravity will be acting downwards on the bucket and we will be pulling in the upward direction, that is opposite direction. More effort will be used. But when a pulley is used, what happens? Here we are applying force in the downward direction and the force of gravity is also acting in downward direction. So pulling the rope, that is lifting the water in a bucket from a well, becomes easier when this pulley is used. Okay, this pulley helps us to pull it in the downward direction. This boy can easily pull the water in the bucket in downward direction with less effort compared to pulling it without the use of pulley. That is, he will have to lift it in the upward direction. More effort he will have to apply. Again, in this case also, the mechanical advantage will be equal to 1 because load and effort are equal. Okay, so in order to lift a heavier bucket, more force he will have to apply. That is, more effort he will have to apply. When it comes to a smaller bucket, less effort is only required. So depending on the load, the effort will also change. Therefore, the ratio, that is mechanical advantage is equal to load by effort. When they are equal, mechanical advantage is equal to 1. What about velocity ratio? Depends on the velocity, right? If he is pulling with a greater velocity, what happens? The bucket will be moving faster, which means they are also in the same pace. That is, when one increases, the other also increases. Velocity of effort to velocity of load will also be equal to 1. So in these two cases, that is convenient point and convenient direction, the mechanical advantage and velocity ratio we are getting equal to 1. Okay, we have studied the 4 important uses of machines. With this, we can make a definition for machine. Machine is a device by which we can either overcome a large resistive force or load at some point by applying a small force or effort at a convenient point and in a desired direction, or by which we can obtain a gain in speed. All the 4 uses are coming here. That is, resistive force, a large force, that is a load, can be overcome with the small force, that is effort. Force multiplier. Here force multiplier, convenient point, convenient direction, and the gain in speed, speed gainer. This is how machine helps us. Study this definition for a machine. Okay, using all the 4 uses, how the machine helps us, we have made a definition for machine. Next important term is efficiency. Efficiency is also a word you all are familiar with. We'll be saying some people are more efficient compared to the other. Some are more powerful. What does it mean? So efficiency is a quality, right? Okay, here related to machines, we'll be defining efficiency. Before that, you need to understand 2 important terms, that is work input and work output. Input work and output work. So input work is, for example, when you are cutting with the scissors, you are applying a force on the handle. That is the work you are doing on the machine. This is what work input is. The work done on the machine by the effort is called work input. Okay. So while cutting, the blades are moving through the cloth. Okay. Blades are moving through the cloth. So on the blades, a force is being applied by the machine. Machine is applying a force on the blade. A work is being done by the machine on the blade. Okay, so this is what work output is. Work input is machine, the work that is done on the machine, and work output is the work that is done by the machine. Okay, work done by the machine on the load is called work output. Understood work input and work output. Now we can understand what efficiency is. Efficiency is represented using a letter eta. This is a Greek letter. Greek letter eta is used to represent efficiency. Okay, efficiency depends only on these 2 factors, that is output work and input work. Efficiency of a machine is the ratio of the work done on the load by the machine to the work done on the machine by the effort. That is simply, it is work output by work input. This is how you can find efficiency. For example, when 100 joules, work is always expressed in joules. 100 joules of work is done on the machine. On the machine, that is, this is the effort. Okay, 100 joules. And the machine is doing a work of 500 joules on the load. Okay, in this case, what is the efficiency? Eta. Eta will be equal to work output. Work output is 500. 500 joules divided by work input, which is 100 joules. You will be getting 5 as answer. So remember one important point, that is, this cannot happen. Okay, this is never going to happen. Work output cannot be greater than work input. Clear? Efficiency value can only be less than or equal to 1. It cannot be greater than 1. So 5 is a value greater than 1. Here, when 100 joules of work is done on the machine and the machine is doing 500 joules work, this is not possible. Okay, the reverse can happen. That is when a 500 joule of effort is done on the machine and the machine does 100 joules. With a simple example, you can understand. Consider the case of a tube light or a bulb. What is happening? Electrical energy is getting converted into light energy. Just only light energy? There is some wastage of energy. What is happening there? Yes, in that case, some heat energy is produced. That is, initially we had the electrical energy. It's not getting completely converted. We know according to the law of conservation of energy, energy can neither be created nor be destroyed. It can only be transferred from one form to another. Here, electrical energy is getting converted into useful light energy, but wastage energy is the heat energy. In that case, we will be having the work output, energy output being less than the energy input. Okay, you can use only the useful part. The wastage part cannot be included. Efficiency value will always be less than or equal to 1, never greater than 1. And efficiency is always expressed in percentage. Say 100%, 20%, 30% efficient. Clear? Now we will be understanding the principle of a machine. How much efficient it is. Okay, effort point and load point. What is effort point and load point? Here you can see the person is trying to lift the rock. What is he doing? This rock is the load, stone is the load. Okay, he is applying a force here. This place where the force is applied, the point where the effort is acting, this is the effort point. Okay, and the place, the point where the load is acting is called the load point. The point at which energy is supplied to a machine by applying effort. Here we are applying effort at this point and this is a effort point. And the load point is the point where energy is obtained by overcoming the load. At this point is where there is the load is acting downward in order to overcome. The force is being applied using the machine and here the overcoming happens. This resistive force is acting here. So this is the load point. Clear? So in case of a machine, we can understand that there is energy conversion happening. Okay. According to the law of conservation of energy, new energy cannot be formed. Energy can neither be created, it can never be destroyed, but can only be changed from one form to another. We have studied many examples in the previous chapter. So when this transformation of energy happens, some energy is getting lost, right? Some energy is being lost as a wastage. So here, the useful work done by a machine, useful work done will always be less than the input work, or the useful energy that we are getting will always be less than the input energy. Okay. Now, how to calculate the energy? The input energy will be equal to work done on the machine by the effort. Okay, effort is doing a work on the machine. This will be giving us the input energy. It will depend on the effort. Here the force is effort. Work done depends on the effort and force and displacement. What is the displacement? Displacement is the point at which the effort is acting into displacement of the point at which effort acts. So this will be giving you the input energy, effort into the displacement. What about output energy? Output energy will be the work that is done by the machine on the load. It will be equal to load into the displacement of the point where the load acts. Okay, this force acts on this point, and displacement of this point is the displacement of the point at which load will act. That into load will be giving you the output energy. This is how you can find the input and output energies. Depending on the efficiency, we have two types of machine: ideal machine and actual machine. Ideal machine is actually not a real concept. Okay. In case of ideal machine, we will be having the eta value, efficiency value equal to 1. Which means in that case work output will be equal to work input. 100 joules of work is done on the machine and 100 joules of work is done by the machine on the load. In that case, you will be getting efficiency eta equal to 1. There is no loss of energy. If you take the case of a bulb, okay, if the electrical energy is getting completely converted to light energy, electrical energy getting completely converted to light energy. So just a virtual concept, right? Anyway, when the bulb glows, there is some wastage as heat energy. If it gets completely converted to light energy, then you can say that the bulb is a ideal machine. But this don't happen in real life. Okay, a machine is that, an ideal machine is that in which there is no loss of energy in any manner. Okay, here the efficiency value will be equal to 1. In percentage, 100% efficient. The machine is 100% efficient. That is, work done by the machine and on the machine should be equal. In that case, when you take, there is no machine that is an ideal machine. It is just an imaginary concept. Actual machines are real case. Real cases with an actual machine. The simple example of a bulb. What is happening to electrical energy? Electrical energy is getting converted to light energy and heat energy. Yes, in case of an electrical bulb, electrical energy is converted to light energy and heat energy. This heat energy is a wastage of energy, right? We don't need this energy, but still this energy is produced in this case. Okay, let us say some 80% of the electrical energy gets converted to light energy and the remaining is 20%. This 20% is heat energy. This heat energy we don't need. Therefore, this is a real concept. In that case, eta value will be less than 1. Efficiency will be less than 1. It can be 90%, 80%, 70% efficient, not 100% efficient. And the efficiency can never be greater than 1. 110% and all cannot happen. So in an actual machine, the output energy is always less than the input energy, which means work output will be less than work input. Okay, and efficiency of an actual machine is always less than 100%. Understood? Efficiency is something that has no unit. It is a ratio, therefore there is no unit. Clear? So this is the idea about an ideal machine and actual machine. Another example for actual machine, a car that is traveling. So we know that the chemical energy is getting converted to mechanical energy. This mechanical energy helps a car to move. Is it only mechanical energy? There is heat energy. Due to friction, heat energy is produced, noise is produced, sound energy is produced. The sound energy, heat energy are wastage of energies. So the complete chemical energy is not getting converted to mechanical energy. Okay, it may be due to frictions. Friction is happening and due to this friction, there is some loss of energy. So actual machines exist, ideal machines is a imaginary concept. Next, we are going to find the relationship between efficiency eta, mechanical advantage and velocity ratio. Suppose a machine overcomes a load by the application of an effort. Okay, then there will be displacement of effort and displacement of load. Displacement of effort dE. dE is taken as the displacement of effort. And we'll be having dL. dL will be the displacement of load. Okay. Now, to find efficiency, we have efficiency is equal to work output divided by work input. In this case, what is the work input? What is work input? Work input will be the force. That is, here the force is effort. Okay, effort into displacement of effort. We know that work is force into displacement. In this case, the force is the effort and the displacement is displacement of effort. Okay, that is E into dE. Work input is E into D. Similarly, what is the work output? Work output will be equal to load into displacement of load. Load into displacement of load. Okay, that is L into DL. Now we have efficiency eta is equal to work output divided by work input. Here work output is equal to L into DL divided by work input is E into DE. Okay, this can be written as L by E into DL by DE. Okay, now what I am doing is I am taking this part L by E. What is L by E? L by E, we know L by E is the mechanical advantage. Also we know that DE divided by DL is velocity ratio. Here we have DL divided by DE. DL by DE will be the reciprocal of DE by DL. Okay, so this can be written as eta is equal to L by E is mechanical advantage. Okay, into DL by DE. DE by DL is the velocity ratio, which means DL divided by DE, taking the reciprocal, will be 1 by VR, 1 by velocity ratio. So this is 1 by velocity ratio. Eta is equal to mechanical advantage divided by velocity ratio. Okay, which means we can write mechanical advantage is equal to eta into velocity ratio, which means mechanical advantage is the product of efficiency and velocity ratio. So this is a relation between efficiency, mechanical advantage and the velocity ratio. So that is mechanical advantage of a machine is equal to the product of its efficiency and velocity ratio. Clear? This is how we can derive a relation between mechanical advantage, velocity ratio and efficiency. Okay, let us take an example. A machine is driven by a 100 kg mass that falls 8 meter in 4 seconds. It lifts a load of mass 500 kg vertically upwards. Taking G is equal to 10 meter per second square. We have to calculate first one, the force exerted by the falling mass. Second, the work done by the falling mass in its displacement by 8 meter. Then the power input to the machine. The power output of the machine if its efficiency is 60% and the work done by the machine in 4 seconds. Okay, first let us find the force exerted by the falling mass. How to find force? Here what are the given quantities? We have mass given. Mass M is equal to 100 kilogram. That falls 8 meter. 8 meter is the displacement. Okay, or the height is 8 meter through which it falls. Displacement D is equal to 8 meter. Time is given. Time T is 4 seconds. It lifts a load of mass 500 kg. Load is given. Load L is equal to 500 kilograms. Vertically upwards, taking G is equal to 10 meter per second square. G is 10 meter per second square. We have to calculate the first one, that is force. How to find force? Is equal to, here force is mass or the weight of the body, which is mass into acceleration due to gravity, M into G. What is the mass here? Here mass is given 100 kilogram. 100 into acceleration due to gravity, G is 10. Okay, 100 into 10, 1000. What is the unit of force? Newton. Okay, 1000 Newton. 1000 Newton is the force. Next, what we need to find? B part, we have to find the work done by the falling mass. Work done, W is equal to force exerted by falling mass into displacement. Okay, this is how you find the work. Work is force into displacement. Here force exerted by falling mass we already has determined. Yes, this is mg into d. Mg we have already determined, which is 1000 Newton. 1000 Newton into the displacement here is 8 meter. which is 8000 unit is joules. So the work done will be equal to 8000 joules. Work done by the falling mass is equal to 8000 joules. Next, the C part, we have to find the power input to the machine. Power input to the machine. How to find power input? Power input will be equal to work done on machine divided by, power is work by time, therefore power input will be the work which is done on the machine divided by time. Here work done on machine we have determined, which is 8000 joules. 8000 joules divided by time taken is 4 seconds. 4. 8000 divided by 4, which is 2000, unit of power is watts. Okay, 2000 watts. Next, we have to find the output power of the machine if its efficiency is 60%. Efficiency is given. Efficiency eta is equal to 60%. 60% is 60 divided by 100, which is 0.6. Okay. And we know that efficiency is equal to power output divided by power input. Okay. Here efficiency is 0.6. 0.6 is equal to, we need to find the output power. Power output divided by power input we have determined, which is 2000 watts. 2000 watts. So to make the calculation easier, we can take this as 60 divided by 100 itself. Okay. So the power output will be equal to 2000 into 0.6 is 60 by 100 or 6 by 10. Cancelling, we get 200 into 6, which is 1200. Unit is again watts. So last part, we have to find the work done by the machine in 4 seconds. Work done by the machine in 4 seconds. Here we know that power is equal to work by time. We have determined the input power. Input power is work done on machine by time. Therefore, output power will be equal to work done by machine divided by time. Then what is work done by machine? It will be equal to output power into time. Okay. Power output into time. That is equal to, power output is 1200 into time taken 4 seconds. 1200 into 4 will be equal to 4800 joules. Okay, work done, unit is joules. We have determined all the 5 parts. Clear? That's all for today. In today's class, we have discussed the basic concepts about machines. What are the uses of machines, definition of machines, efficiency, etc. Hope you all enjoyed the session. I'll be back in the new session with a new topic. Until then, stay tuned to Learno Hub. Learno Hub free hai par best hai. Thank you.